Hi kids. So in the previous video we have already discussed the Pythagoras theorem and its converse. In this video let us solve sums from ML Aggarwal exercise 12 from sum number 16 to 26. Mainly it consists of the proving sums which are very important. Now let us see sum number 16 part A. In the given figure below, BC is equal to 5 centimeter. Angle B is 90 degree. AB is what is given to us. AB is 5 times AE. CD is twice of AE. And AC equals to ED. They have given this. Okay. Calculate the length of EA, CD, AB and AC. Now look carefully. Suppose I take AE as X, then AB becomes 5 times X. So this is 5 times X, which means EB, if you look carefully, will be 5X minus X, which is 4X. Then CD becomes twice of AE, that's twice of X. So CD becomes twice of X. Now look, there are two right angle triangles. First of all, we need to search the right angle triangle. ABC. In triangle ABC, angle B is 90, so AC is the hypotenuse. So we can say by Pythagoras theorem, AC square is equal to AB square plus BC square. Now, if you look at the triangle EBD, right angled at B, in triangle EBD, of course ED is the hypotenuse, so ED square is equal to EB square plus BD square. Now look carefully. AC is equal to ED, which means AC square will be equal to ED square, which means can I write AC equals to ED, which means AC square equals to ED square, which means we can equate AB square plus BC square is equal to EB square plus BD square. Done till now? Now we'll substitute the value. Instead of AB, 5x. So this is 5x whole square plus BC, that's 5 square. Just look carefully. EB 4x whole square. BD if you look carefully is 5 plus twice x. 5 plus twice x whole square. Done. Now we need to solve this equation. See, 5x whole square is 25x square plus 25 is equal to, this is 16x square plus, this is a plus b whole square, that's a square plus b square plus twice ab, which means 5 2 are 10, 20x. Am I clear? Now look, 25x square minus 20x square, which means 5x square, and this comes on this side, so minus 20x. Okay, this cancels out, equals to 0. Which means I can take 5x common, so x minus 4 equals to 0, which means either 5x equals to 0, which means x equals to 0, not possible, and x minus 4 equals to 0, which means x equals to 4. So that's the possibility. So the value of x is 4. Now once you get the value of x, see, then AB, they're told to find AB, 5 times AE. AE was x, so 5 times x will be 5 4s are 20. Done. EA, we got it, that was x only, that is 4. This is also done. Then CD is twice of AE, which means 2 times this, which is 8, and AC they want. We'll solve this. Look over here. AC square equals to AB square, which is 20 square, plus BC square. Now BC is 5 square. 5 square is, okay, so AC square will be 400 plus 25. So AC square will be 425. So AC will be root of 425, isn't it? Which means this becomes 5 root 70. Oh, these are all in centimeters. Done? Clear? Now let us look at the next sum. Now look at this sum, 16 part B. In the figure, ABC is a right angle triangle, right angle at C. If D is the midpoint of BC, prove that AB square is equal to 4 times AD square minus 3 times AC square. Pretty easy. First of all, there are two right angle triangles if you see. Triangle ABC, where AB is the hypotenuse. So AB square is equal to AC square plus BC square. Now, another triangle is triangle ADC, where I can say AD is the hypotenuse. So AD square equals to AC square plus DC square. Now look carefully. AB square equals to AC square plus BC. Now, D is the midpoint, which means BC will be twice of DC. No doubt in that. So twice of DC whole square. We can write this, which means AB square equals to AC square plus 4 times DC square. Now from here, if you look carefully, DC square is AD square minus AC square. Substitute the value. So AB square is equal to AC square plus 4 times. Instead of DC square, I can write AD square minus AC square. Simplify it. So AB square equals to AC square plus 4 times AD square minus 4 times AC square, which means AB square equals to 4 times AD square minus 3 times AC square. Proved? Done. Now let us see the next sum. Now look at sum number 17. In a triangle ABC, AB equals to AC, that is equal to X. BC is 10 centimeter, which means it's an isosceles triangle. And area of triangle ABC is 60 centimeter square. Find X. We'll first draw the diagram. The diagram is always important. See, I've drawn a triangle ABC, where BC is 10 centimeter, AB is X, and AC is also X. And the area of this triangle is given as 60 centimeter square. Find X. Now we know in an isosceles triangle, if you drop a perpendicular from A on BC, suppose AD, then AD is perpendicular on BC and AD bisects BC, which means BD and DC will be same, which is 5 centimeter each. We know this property. Now look, area of this triangle, can I write half into base into altitude, which is AD. We can write like this, which means area is 60, half, BC is 10, AD, we don't have any idea. Okay, so this is 2, 1 times 2, 5 times 5, 12 times, which means AD is 12 centimeter. Now look at the triangle ADC. Okay, any triangle ADB or ADC. I'm taking triangle ADC. Look carefully. AC is the hypotenuse, so AC square will be equal to AD square plus DC square, which means AC square will be AD. AD is how much? 12 square plus DC is 5 square, which means AC square will be 144 plus 25. AC square is 169, which means AC will be plus minus 13. We'll take positive value, which is 13 centimeter. and that is x only. So x is 13 centimeter. Solved. Done. Now look at sum number 80. In a rhombus, if diagonals are 30 centimeter and 40 centimeter, find its perimeter. We should know the property of all these figures, you know. Now, in a rhombus, we know that the diagonals are perpendicular and they bisect each other. Which means if I draw the diagram, suppose I draw a rhombus. So this is your diagonal. Okay, suppose A, B, C, D. This is O. So we know that AC and BD are the diagonals in this case, and they bisect each other at O at 90 degree. Which means AO will be equal to OC and DO will be equal to OB. Now look carefully. Suppose AC is given as 40 centimeter and DB or BD is given as 30 centimeter. Now look, AO will be half of AC, which is 20 centimeter, and OB will be half of DB, that's 15 centimeter. Now look at triangle AOB. In triangle AOB, if you look carefully, AB square, AB is the hypotenuse, is equal to AO square plus OB square, which means AB square will be, AO is 20. So 20 square plus 15 square, because OB is 15. So AB square is equal to 20 square is 400 plus 15 square is 225, that's 625. Which means AB will be root of 625, that's 25 centimeter. Once you got the side of a rhombus, we know all the sides are equal, which means perimeter will be equal to 4 into AB, that's 4 into 25, that's 100 centimeter. Done. Now let us look at the next sum. Now look at sum number 20. AD is a perpendicular to the side BC of an equilateral triangle ABC. Prove that 4AD square is equal to thrice of AB square. Pretty easy. First of all, I told you diagram is very important. Draw a equilateral triangle. Suppose this is A, B, C. AD is the perpendicular to the side BC, which means you drop a perpendicular D. Now we know the perpendicular AD bisects BC into two equal half, which means BD and DC will be same. Okay. Prove that 4AD square is equal to thrice of AB square. Now pretty easy. Just look. In triangle ABD, triangle ABD, AB square, because that's the hypotenuse, AB square is equal to AD square plus BD square. Done. Now look, BD I can write half of BC, so AB square is equal to AD square plus BD is half of BC square. Correct? And BC and AB are equal, so instead of BC, can I write AB? So AB square equals to AD square plus half of AB whole square, because of course BC and AB are same. It's an equilateral triangle. Now just solve it. AB square equals to, this becomes AD square plus AB square by 4, which means AB square minus AB square by 4 equals to AD square. Okay. Now 4 taken LCM, so 4AB square minus AB square is equal to AD square. Now this is thrice AB square is equal to 4 times AD square. Proved. Okay. Now let us look at the next sum. Now look at this sum, very interesting. Sum number 21. In the figure, D and E are the midpoints of BC and CA respectively. If a triangle ABC, right angle at C, prove that there are 3 things to be proved. First of all, 4AD square equals to 4AC square plus BC square. 4b square equals to 4bc square plus ac square, and 4 times bracket ad square plus b square equals to 5 times ab square. Step by step. First of all, look. Take the triangle ACD. I'm trying to prove the first part. Triangle ACD. Right angle at C, which means AD is the hypotenuse. So AD square equals to AC square plus CD square, no doubt. So AD square equals to AC square plus, now D is the midpoint, which means CD and DB are equal, which means I can write CD is half of BC, okay, which means this we can write CD will be BC by 2 whole square, which means AD square equals to AC square plus BC square by 4. So AD square equals to 4. This is 4 AC square plus BC square. 4 goes over there. 4 AD square equals to 4 AC square plus BC square, which was the first part. Done. Now, suppose this is your number 1. Now, part 2C, how I prove. Look at the triangle ECB. Okay, in triangle ECB, if you look carefully, BE is the hypotenuse because it is right angle at C. So BE square is equal to CE square plus BC square. No doubt in that. Now BE square. Now again, E is the midpoint of AC, which means AE and EC are same, which means EC will be half of AC. So instead of CE, can I write half of AC, which means AC by 2 whole square C? EC or CE, whatever, is half of AC, which means plus BC square, which means BE square, just open the bracket, AC square by 4 plus BC square. Take LCM and proceed. BE square equals to AC square plus 4 times BC square by 4. So 4BE square equals to AC square plus 4BC square, which was the second part. Done. Now for the third part, what I'll do, I'll add these two. Just look over here. Add 1 and 2. 4AD square plus 4BE square is equal to 4 plus 1. This is 5AC square plus 4 plus 1 again, 5BC square. See, if you add equation 1 and equation 2, the left hand side added to the left hand side and the right hand side added to the right hand side. So we'll get something like 4 bracket AD square plus BE square is equal to 5 times AC square plus BC square. Now if you look carefully, one more step, AC square plus BC square in the bigger triangle ABC. In triangle ABC, right angle at C, AB is the hypotenuse, so AB square is equal to AC square plus BC square, which means instead of AC square plus BC square, I can write AB square. And that was a third part. Done. Now let us look at the next sum. Now look at sum number 23. In the adjoining figure, the diagonal AC and BD of a quadrilateral ABCD intersect at O at a right angle. Prove that AB square plus CD square equals to AD square plus BC square. Now you see carefully, there are 4 right angle triangles. First, let us see triangle AOD. Over there, AD square, since AD is the hypotenuse, is equal to AO square plus OD square. Okay. Then you look at triangle DOC. Triangle DOC. Again, over there, DC is the hypotenuse. So DC square or CD square is equal to OD square plus OC square. Suppose this is equation 1, this is equation 2. Now look at triangle AOB. Triangle AOB. Over there, AB square, look carefully, AB square is equal to AO square plus OB square. Done. Now there's one more triangle. Suppose this is your equation 3. And the last triangle BOC. In triangle BOC, BC square is equal to OB square plus OC square. Done. Suppose this is 4. Now look carefully. This is AB square plus CD square. AB square plus CD square. So we'll add these two. Adding 2 and 3. 2 and 3. What do we get? See, AB square plus DC or CD is the same thing. CD square is equal to AO square plus OB square plus OD square plus OC square. Done. Now I'll just arrange the right hand side. Now this I'll write is AO square plus OD square. I'll just rearrange. OB square plus OC square. Now look carefully. So AB square plus CD square, okay, is equal to AO square plus OD square. Look over here. This is AD square plus OB square plus OC square is nothing but BC square. Proved. Done. Now let's look at the next sum. Now look at sum number 24. Pretty easy. In a quadrilateral ABCD, angle B equals to 90 equals to angle D. Prove that twice of AC square minus BC square equals to AB square plus AD square plus DC square. First of all, draw the diagram. See, I'll take, this is your BA, BC, then D is, suppose I take something like this, okay, and this is also 90. Clear? There are two right angle triangles. In triangle ABC, just look over here. In triangle ABC, AC square is equal to AB square plus BC square. Done. Then look at triangle ACD. Triangle ACD. Again, AC is the hypotenuse. So AC square equals to AD square plus DC square. Now I'll add these two. Suppose this was equation 1 and this is 2. So adding 1 and 2. What do you get? AC square plus AC square is twice AC square is equal to AB square plus BC square plus AD square plus DC square. We'll bring BC square on that side. Is this side. So this becomes, yeah, this is done. Look carefully. Twice AC square minus BC square equals to AB square plus AD square plus DC square. Pretty easy. Now let us look at the next sum. Now look at sum number 25. In a triangle ABC, we'll draw the diagram also. Angle A is 90 degree. So this is your A, B, C. This is 90. CA equals to AB. So these two sides are equal. And D is a point on AB produced. So you produce this AB. Suppose D is this point. We'll join CD. Done. Prove that DC square minus BD square is equal to twice of AB multiplied by AD. Pretty easy. Just look over here. Look at the bigger triangle ACD. In triangle ACD, DC square, since DC is the hypotenuse, DC square is equal to AC square plus AD square. No doubt in that. Pythagoras theorem. Which means DC square is equal to AC square plus, instead of AD, can I write AB plus BD? So this will be AB plus BD whole square. So DC square equals to AC square. We'll just open this. So this is AB square plus BD square plus twice AB multiplied by BD. What I'll do, see BD square is on this side. So I'll bring this BD square on this side. So DC square minus BD square is equal to AC square plus AB square plus twice of AB multiplied by BD. Now look carefully. AC is equal to AB. So instead of AC, can I write AB? So this becomes DC square minus BD square is equal to, instead of AC I write AB square plus AB square plus twice AB multiplied by BD. Done. Now look, this is DC square minus BD square equals to twice AB square plus twice AB multiplied by BD. So this is DC square minus BD square is equal to twice AB if you take common. This is AB plus BD. And if you look carefully, AB plus BD is nothing but AD, which means DC square minus BD square equals to twice AB multiplied by AD. Done. Now let us see the last sum. Now look at the last sum for this exercise, 26. In an isosceles triangle, ABC, AB equals to AC. So I'll draw an isosceles triangle. Look over here. A, B, C, such that AB is equal to AC. And D is a point on BC produced. So I'll produce BC, and this is your point D. Okay. Prove that AD square is equal to AC square plus BD multiplied by CD. Now look carefully. What I'll do, I'll drop a perpendicular on BC from the vertex A. Suppose AM. Okay. Now, we know in ABC, since it is an isosceles triangle, then the perpendicular AM bisects BC, which means BM will be equals to MC, which will be equal to BC by 2. Now look carefully. In triangle AMD, AD square is equal to AM square plus MD square. Now AD square is equal to AM square plus MD can be write as MC plus CD whole square. Now AD square is equal to AM square plus, we'll just open the bracket. So this will be MC square plus CD square plus twice MC multiplied by CD. Done. Now look at triangle AMC. Triangle AMC. Over there, AC square can I write as AM square plus MC square. Now back to this equation. Just look over here. We had equation 1. Suppose this is equation 1. We had AD square is equal to AM square plus MC square plus CD square plus twice MC multiplied by CD. Now look, instead of AM square plus MC square, can I write AC square? Definitely. So AD square equals to AC square plus CD square plus twice MC multiplied by CD. Now look over here. MC equals to half of BC. So we'll substitute the value. So AD square equals to AC square plus CD square plus twice into MC will be half of BC. So BC by 2 into CD. This cancels out. Am I clear? So AD square is equal to AC square. We are almost there. Plus CD square plus BC multiplied by CD. So AD square is equal to AC square plus CD taken common. So CD plus BC. So AD square is equal to AC square plus CD, and CD plus BC is nothing but BD. And this is what we were supposed to prove. Hence done. Okay. So keep it till here in this video. In the next video, we'll look at a new chapter. Till then, take care.